My name is Elina. I'm a production engineer at Facebook. So today I'm going to tell you about Facebook site reliability. So I will go and tell you who we are, what we are doing, what issues and failures did we have, and what lesson we learned. So first, who we are. Production engineers are kind of mix of software engineer and system administrator. We deal with problems of running services in highly distributed systems. We build infrastructure to let software engineers to build their awesome and complicated servers like ads platform or photo storage platform. My particular team is Web Foundation. As you can get from the name, we are taking care of site. So we're making site up and running all the time. But it's not about uptime. It's mostly about making it run reliable and fast. My team is small. It's like really small. And tools we built enable such a small group of people to monitor and work with such huge thing as Facebook. But it's still not obvious what we are doing. All of you realize that Facebook has a huge infrastructure and something is broken all the time. So are we firefighters? Or are we proactive and preventing fires? Of course we have fires, but things got not so often. So we're really good at proactive work. And you know, I really don't like words like firefighters or fire preventers. They have fire inside. I would like to say that we mostly like doctors. So we are monitoring site reliability at performance metric. We're investigating errors, we're investigating performance issue, all the way from PHP code to kernel. Of course, we are dealing with the incident response. So we drive incident investigation, so if Facebook is down or suffering, we are first people who receive alarms and start investigating, trying to narrow down the problem, what is the issue, and then call other teams to have more context. So we have very good, on-call scheduler for a lot of teams. So it's really easy to spot if this service is broken, who is in charge of. So we grab this person and start dealing with issues with him. And again, it's not mostly about fires. It's like some issues, tiny issues, some weird errors, some weird latency. So we also deal with this. So we are kind of good noticing issue before they become a real problem. And we are promoting best practices. It's the first thing we are doing. As far as we are good at errors investigations and performance issue investigations, so once we find some bad service and find the real problem, we try to spread this knowledge to other people to make them fix it on their parts. And we also good at debugging, so we have talks, write documentation, and make people to use tools we built to make their life easy. As I said, we're kind of hybrid, so software engineers and system administrators. The things I told you before were more related to system administration stuff. But we're also building awesome tools. They mostly related to automation, but we also made some awesome services. Like a little bit of examples. For example, EVPKG is our blob distribution service that based on BitTorrent protocol, so we distribute the large files and software packages to thousands of machines every day, like PHP binary, for example. Kiano, I really like this tool. It's automated load tests. So it performs daily load tests for regions, clusters, subset of hosts, and it makes us find bottlenecks and errors in advance, not when something is already crashing and in fire. Cyborg, easy host provisioning. Just image the host in one click. Global load balancer, it's actually a service, not even an automation. It's a DNS load balancer that has a smart decision engine inside. So it maps users to our data sensor in a really smart way. CT scan. I never used it because I have nothing in common with mobile testing, but this thing is really awesome because it's not just a software. They actually built a rack of smartphones. So they perform A/B testing using the rack of smartphones. It's like amazing. Cobalt automated cluster provisioning. So it allows us to provision image brought online and make clusters serve production traffic like in terms of days. Dapper maintains automation. Also cool. So data center guys, they can migrate data from broken hosts. They even can decommission the whole cluster and don't even touch us. They do it by themselves with this thingy. FBAR, I also like this thing. It is automatic remediation. So if one host has a hardware failure or operating system failure or some issue, this thing comes and fixes. And we have never deal with one particular host. So if something is broken, it's usually like hundreds of thousands. So if it's one, that guy did it for us. So the list of tools we built is huge. And every tool is worth to have a separate talk. So let's move back to how we are looking for a site. Monitoring. What we are monitoring? There are three major metrics we receive alarms. Egress, 5x axis, and latency. Egress is really low-level metric. It shows how many bits we send users back from our internal network. It has nothing to do like per request or whatever. It's just how many bits per second we send to users. So it's really low level, but if this metric goes down, that means something is broken. It could be network, it could be service overload, it could be broken PHP, it could be broken JavaScript. But if egress goes down, something is wrong. 5x axis, really easy, HTTP error. If we return to users errors, that means something is wrong. And latency. This is a tricky one. Because if we will monitor average latency, so latency is how much time we spend processing requests from users. We don't care about average. We care about P99 latency. So brief introduction to the percentile world. So if we have a bunch of events and latency for each event, if we sort them from low to high, take 99% and grab the upper bound, it will be P99. Super easy to see normal distribution graph, but real world is different. This is the real graph for latency for web request. So you can see that from the left side, there is a spike. So we have a lot of requests that have small latency. And it's okay. It's all the time like this. So we care about right things. This small tail, and it has to be small. If it goes up, something is definitely wrong. So these things we receive alarms. So how we monitor others. This is a traditional dashboard. I think you all have seen them. Why it's bad? Each graph has a different period. One per day, another per hour, another per month. And it's really hard to find correlation. So on the first graph, you see this orange line, and it's really not obvious that in the second graph, the same line is the blue one. So what do we use? Every day. This is the awesome Cubism. Cubism is just a JavaScript library for time series visualization. It's open source, Apache license. You can all use it. And what's cool with this? So it's 1 day wide, 1 pixel per minute. This one shows P99 latency, actually. So each line represents the pool of web servers. We have 1 page per metric. It's also cool because it has locality. Two close lines, they are in one region. So, like this. Each color represents one region. So if we see spikes in a group of lines, that means it's a region problem. So we can have some clue about what's going on. But let me explain what are these shades, 50 shades of green are. Because it's green, there are no red. Everything is green, it's like weird. So how it works? It's really awesome. So you have, this is an ordinary graph. You can see spikes, you can see outliers, you can see this like bump in the middle and some weird thingy at the beginning. But it consumes a lot of space. It's like 120 pixels high. So if we squeeze it, it is like, what? Really? What can I see here? Something green. So what cubism do? It divides graph into sections. Darker means worse. And then wrap them. Bum, bum, bum. So now you can still see the shape. You can still see like tiny spikes because it's like 1 pixel per minute. But it consumes less space. So back to our awesome cubism. Each dark means actually the spike. So how we use it? With this thing, it's really easy to spot weird events and also skip known ones. For example, that thing that is in right upper corner, like these bumps, like stair. I know this is load test. I don't care. But that guys in the blue oval, they are weird. I've never seen such spikes before. So I'm going to investigate. But this is latency. What caused latency? Maybe network, first blade network, all the time. Go to cubism for network. So what we look for if we think that we have network issues. We measure TCP retransmits. So TCP is a reliable protocol. If something is wrong, like saturated reg switch, fiber cut, you will get retransmits. And at this particular time, at this region, there were no retransmits. Not network. Back to latency. So I will check graph for CPU utilization, backend services latency, web servers crashes, and bingo. That one is for cache outliers. So cache outliers, this graph represents the amount of requests we spent a long time waiting for cache. Okay, we got it. This is cache. What's next? If I press with the mouse on the particular line, the cubism will redirect me to the ordinary graphs. Again, high-level things. CPU, crashes, latency, cache-specific things like hit rate. So from this thing, we narrow down the problem like say, okay, these cache machines consume a lot of CPU. And we go deeper, log into the particular machine, and try to look for logs, system stats, like use tools, all you know, like ATOP, SAR, SF, and others. Tracing them with perf and BCC tools. Also, of course, the main thing, GDB. So I tell you the whole path, actually, from monitoring to debugging. This is like normal day, normal monitoring day. Because also, you know, we have to also build tools, unless who will do it for us? Let's move to the real incidents. So I told you, we receive alarms, narrow down issue, connecting with teams, trying to solve problem together. But the interesting question is, who breaks the site? This is anonymous, but you cannot see him. This is weird. But this is anonymous guy. So who breaks the site? Hackers, of course. No. Insiders, like, no, really no. I've never seen issues that were caused by hackers or insiders or some bad people. All the time it's our engineers. So, and really, every time they just want to make things better. There was a story, I heard it from my colleagues, it happened a couple of years ago. Facebook was down for a couple of hours. And the most ashamed part of this crash was that engineers even couldn't log in to their dev servers to fix the problem. So it was like, what? Brief introduction to this issue, how it works, and what was the problem. So we have such a service discovery. So then Facebook user try to log in and go, not even log in, just send a request to PHP servers. They go for load balancers, and load balancers ask service discovery thingy where to go, where to route the request. The same path is for engineers to log into their dev servers. And what happened? This service discovery guy had a bug. Some engineers, he didn't know this. He added a batch record to this service. And he could add it, but when then load balancers tried to read from it, they got an error all the time. So nobody could log into the internal network. Thanks God, there was another engineers. They already had established SSH session to their dev servers, Mosh. So it was super obvious what was broken. So they manually go to this service discovery system, remove the batch record, world was safe. It was super easy just to fix the bug and forget. Like, this issue was really crazy, bad record. We will never add another bad record to this system. But we go further. Every time we go further and try to solve the issue and learn from our errors. So we fix service discovery client to ignore suspicious updates. We created a path to engineers to log into their dev servers directly with not touching load balancers and everything in case of emergency. And also we created an emergency communication tool, because when you cannot log in, you cannot use internal tools, and all communication tools were internal tools. So we did also this. So that issue triggered like so much follow-ups that improved site reliability. But that was like a long time ago. It's actually a legend. Everybody knows this story at Facebook. Now we don't have such big outages because we are learning on every big one and improving our infrastructure all the time. But I still have some story to tell you. This story happened a couple of months ago. I was on call. I received an alarm about egress drop. And it was like, oh, I'm scary. What's going on? As far as we are in charge of web servers, so I went to Kubizm, checked the front-end clusters, and everything was calm. Like 5x access, fine, latency, fine, TCP, network issues, fine, CPU utilization, fine. There were even small drop on this. So what does it mean when you have drop on 5x access? That means you don't have requests. But network was fine. I think network people like maybe fiber cuts, maybe whatever, no. Going higher, load balancers. But again, I need some brief introduction. So we have POPs, points of presence, and we have big data centers. Points of presence only deal with load balancing and SSL termination. So they let this SSL and TCP handshake be slow or shorter. And they already have established SSL connection to the main data center, so they wrote this request tunneling to the big one guy. And also, we have everything running inside the containers. It's like Docker, but we have our own system. So the container manager is in the main data center. It controls every host, and in each host you have a daemon who actually does the real job, like set up a root, run a container, run task you want. So what happened? We lost all load balancers and a couple of POPs. So users could not connect from them, and as far as the IP address of these guys we got from DNS load balancers, so they're cached, so users got errors. But why? You already see it in the picture. So container manager couldn't connect to the daemon, local one that actually set up a task and run tasks on this run actually load balancer tasks. He couldn't connect, and this daemon was like, okay, you don't like me anymore, you don't send me commands, I will shut down everything. And he did. And it was because the firewall, because there was a whitelist of machines who can connect to the machines inside the POP. And container manager just moved to another machine, and we got a fail. The easiest issue was to move it back. Like, as soon as we really fast found like what's wrong, and just move it back. And tasks started recovering, and the world was saved again. But it's not the end of the story. Again. So it's worth to mention that this static whitelist of IP addresses was not like our silliness. It was because POPs are SSL termination points, and audit security people, they're crazy. They want us to have firewalls with a static list of IP addresses who can connect to it. So the first thing we did, we started to dealing with them and actually changing the way how do we add hosts to this POPs firewall, because we really want them to be dynamic. We also added smart monitoring to firewall and to create alarms when we block legitimate internal traffic. We also added something to container manager. We added alarms if number of unreachable servers is bigger than X, and we fixed daemon behavior. Like, we don't want him to kill everything if he cannot connect. So again, this issue was not a big one because it was only a couple of POPs. We have a lot of them. But this issue leads us to such awesome fixes. So, thanks. But, okay, so that was our stories. And I also told you that we are promoting best practices. So one awesome story that I like, it's not the fire, it's not a big issue, but it's interesting. So we had a service that works fine under normal load, but at the peak time, it like at the same really fast goes to 100% of errors. It returns 100% of errors. So each request failed. Like this. So it was not a critical service. Users were not impacted. They just didn't get some funny experience, like I cannot tell you, I think. So we investigated this issue and we found out that this service was queuing. What's wrong? You have a high load, you have a queue, this is normal. But there was a thing that, so normal load. I did this awesome animation, I really like it. We proceed the request, fine. High load, stuck, and this is a timeout. Each request had a timeout. Boom, boom. Time is coming, but server still has time to proceed the request. But when the load goes up, 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 and you can see that the first guy is already expired, almost. So server starts processing it and drops it at the middle of processing. So it spends CPU time, it spends resources, but the request was timing out. And this thing happened to every request. So what was the solution? The solution was pretty easy, but it was cool. We had a queue timeout. So if the request spends longer than X milliseconds on the queue, don't do it. Just drop. This is a long animation. So now server can still process the same amount of requests as it did under normal load and dropped others. Bingo. So after this minor fix, we got actually legitimate behavior. So if we add 50% of load, we got 30% of errors. We solved this in one service, but it was not the end of the story. The other part was to distribute this knowledge to other service holders. Maybe they have the same issue. So it also was like a long way. And the last story. It's not even a story. It's best practice, and I really like it. Killing story was about one particular problem. But this thing is a broad thing that we have learned from a lot of outages. Roll everything carefully. We use the word canary for this. So canary configuration, canary new binaries, canary PHP code, like canary everything. And I would like to emphasize that canary is not roll carefully does not mean roll slowly, because we roll pretty fast. We push new PHP code 3 times per day. But rolling in phases don't get servers overwhelmed. So how it works? Super easy. You roll to the small group of servers, check metrics. If you have high memory utilization, high CPU utilization, high error rate, whatever metric you set up for your service, just roll back. And system automatically notifies the offer. But if everything is okay, system continue rolling it, check it again, fine, and repeat it multiple times. So the whole process I just described, of course, is fully automated. And such a system saved a lot of human hours of debugging and fixing broken services. So I'm about to finish the talk. I told you who we are, what we are doing, how do we monitor things, what tools we built, what failures we had, and what lessons we've learned. So thank you for your attention. If you have any questions about Facebook site reliability, you can ask me now, because we have 5 minutes, or later.